talk about header files in this lecture. So both C language and C++ languages, they have header files. We don't use header files for a reason that we'll explain later. The header file extension is .h. In some IDEs like your Xcode, you'll see .hpp. It doesn't really matter which one is which. It is important that if you're sticking with one IDE and is using .hpp instead of .h, stick with it, right? Otherwise, you get into syntax issues. A lot of times, this is what you see in the industry where you have, for example, a CPP file. The CPP file is named my CPP program. Its corresponding header file would be the same name, .h, okay? So you will have a pair of CPP and then h, right, by the same name. And that's what this header file is. It's for declaring all of the function, the classes, as well as global and any macros that you wish to include inside the CPP file, you put them in the H files, right? So in your homework assignments, right, where you have pound include, right, where you have using namespace, right? So these are sort of information that you can include, put them in the header file instead. And what you need to do in the CPP file is to pound include that header file back, right? So this allows you to, or allows the preprocessor to pull the relevant info into your code. But doing so, it also allows you to create an abstraction, or what we call interface, right? In Java, we call it an interface, from the implementation detail. So you can focus entirely your implementation details in the CPP file, whereas header file will have all of the constant, all of the declarations necessary to help or aid your implementations. So this create a cleaner sort of separation of concerns from development standpoint to make your code a lot easier to understand and to maintain, right? To on that level, having a header file in place. The reason, okay, why we're not using header file is because I don't want you to submit, 5 or 6 different files per assignment. You can end up with header file number 1, header file number 2, plus the CPP files. And it just makes your submissions a lot more cluttered than necessary. So a lot of times you can push both the CPP and H files together and merge them together into one file for submission. And this is the reason why we don't use header file. But nonetheless, you should know about these header files and how that is used in relations to the preprocessor directives. So this is an example. In the industry, let's say if you've had several CPP files, right? Demo, CPP, demo 1, demo 2, demo 3, CPP, then you would need to have a corresponding header files. And this is, like I said, to separate, right, the abstraction and the implementation details to make your code a lot easier to maintain. That way, when a developer comes in, they usually read your demo.cpp with there's API documentations in there, right? So these are the commentary stuff that you need to include, or they can refer to your demo.cpp, demo.h rather, and API documentation sits right in there, right? So just by looking at this interface, developer can basically skip over a lot of those constant details and go straight into the implementations. So that's what you have: demo, CPP, H, right? Demo 1.cpp, and then you have demo 1.h, right? So on and so forth. And that's how this works. So let's look at this header files in with more details. From implementation standpoint, let's say if you have a demo.cpp, what you need to do, for example, you may require having both demo.h and demo3.h in that file, right? So in this case, and notice the difference. Now we're talking about this a pair of double quotes, right? Whereas in the past, if you look at pound include, you have this angle bracket, IO string, right? So this angle, right, brackets and this pair of parentheses, there are two different things. One is, this is for pre-existing, basically anything that is built in libs, right? Pre-existing libraries. This is the custom one, or user-defined, okay, or user-defined libraries. So if this is a user-defined libraries, then your project files, typically that's where your project setting is. Specify where your local directory is, where your local CPP and local .h files are located. or there is some sort of custom path in your computer that you would like your project to search into, right, in that case, you'll use the double quotes in that case. But otherwise, if this is a pre-existing one and this is built into your compiler knows where these libraries are located for inclusion. In that case, you use this angle bracket, okay? And that's important to note. Okay, so for the purpose of this discussion, our header files are considered custom or user-defined. So you see currently this double quotes here. Here's the problem. You have demo, let me just close this part. So you have demo CPP and demo 1 CPP. The problem is that both demo CPP and demo 1 CPP, they have demo3.h as an inclusion, right? So this is inclusion number 1, and this is inclusion number 2. Now, assuming that your demo.cpp and demo1.cpp are both required, right, for your software applications. Now, we're running into an issue here where preprocessor will then compile demo.cpp by including demo3. Preprocessor definition, your preprocessor, which is a software compilation type, would also include the demo3, right, for demo1.cpp, right? So this is a duplicate, right? So at runtime, you don't just have one CPP file, you have multiple of them, right? So this leads to multiple .os, but you don't want this demo file 3 to be included at this stage because, right, from a high level, right, global perspective, you only want this demo 3, right, .h to be pulled into your entire source code once, right? And hopefully other, and they will, like other source codes will see it too, because you're compiling them all in the same directory with the same linker, with the same library, and compilers and assembly processors. So in that case, how do you exclude, meaning if demo3.h has already been included in one file, how do you exclude this, prevent this demo.h from being included again, right, in another CPP file, such that the inclusion only happens once? This is where preprocessor definition comes into place. And there is a preprocessor definition that we mentioned earlier. It's called if defined or if not defined. So if you have if not defined, that is spelled out this way. If not defined is IN, right? IFN defined. If not defined, if. So basically what you do is by definition, convention. This is by convention. So by convention, you would capitalize the entire header file and using an underscore to define this macro library, right, or a macro global variable called dem_mode_h. So the processor actually will store this thing somewhere and says, if not defined this before, define this again, right? And once you have it defined, your entire header content will be pulled into it and defined, right? So this is preprocessor definition. Again, there is no semicolon here, okay? This allows your preprocessor to include your entire content if, right, assuming if demo_h has not been set somewhere, right, in process. So this is happening in demo.h. So what about demo1.h? Demo1.h, right, also has the same thing in there, and that is important. Oh, let me close. Let me clear this part. Your demo.h also has the same thing, right? But because in demo.h, your macro has already been set. So this is not necessary again. Therefore, the header content for demo1.h to pull in that header 3 won't happen at that point. So this is a what we call include guard, and this is done by using a macro exclusion directive called if not defined. Okay, so you see a lot of these things too, and obviously the opposite of if not defined is if defined, right? IFDEF. Okay, so there's a lot of that stuff that we that you'll see in a professional code. There is more details to these processor definitions. They're very similar to Pragma, which is something that gets read by your preprocessor in, for example, Visual C++, Microsoft version of C++. But making use of these proper preprocessor definitions or include guard allows you to also set up maybe a block of code that you wish to debug, right? Have debug statements in. So you would say, if not define underscore debug, and then pound, right? And if by including all of your debug code, right, or statement inside of that block of code at runtime, you don't have to have these end, right? These preprocessor definition can also sit in the CPP file. They don't have to be in the header file. But this shows how you can include your header file, your custom defined or user defined header files into a particular file without duplicating it, right? Having this in place is very important. Okay, so this is a quick illustration of the preprocessor definition and how it's used. You can also check for this example. This one is a summary, demo.h. If not define this and that. So this is the correct syntax in how header is used in C++ and also C as well.